Hello, the Resolid team is happy to see you connected. Either it is your first try with the software or you just decided to refresh your knowledge. I am Justina and I am working in Resolid as technical support engineer. Today I will go through the steps as a basics of data scan using airborne data. You got also the email with the link to the data, the same data that I will use in demonstration of the steps. So by downloading that data, you will have the ability to follow the steps and to have the training. I expect that you already installed the software and you have the valid licenses. Today, the training will be concentrated on data scan, and it will be just one short step in Data Modeler. If you have just data scan, it will be also enough. Since last year, Solid started to run also on SpaceX. So now there is a choice which platform to choose. In this training, it doesn't make difference. You can complete the training with both platforms. Couple words about the data. So in the folder which you downloaded, ALS Basics, you have a data from Jyväskylä city. It is a city in Finland. And from all information, probably the most important is that the trajectory and laser data, they are in different eye systems. That's why I will show how to adjust the points to the geoid model. The data, trajectory and laser data, they are at the same coordinate system, so no transformation is needed. About the agenda. So we will go through the project setup, how to change the settings in DataScan, import the trajectories, place blocks for project creation, and import the points. Then after this part, the data will be splitted into the smaller pieces, and we will go to data classification. Like the biggest part will be ground classification. It will contain several steps and some preparation. We will create macros, and later those it can be run on the project, so something as a batch processing. Also, we will classify buildings and vegetation. It was short part about data, and now we can move to the training part. Firstly, we need to create a design file to be able to load data solid applications as well the data. The design file can be created either in SpaceX or Bentley platforms. I will use today Bentley MicroStation. So not MicroStation PowerDraft. Let's create a new file. I'm pressing on the new file icon. The most important thing in creation of a DGN file is the right seed file. I already have picked one from data installation folder. In case you're just starting with the software, then you need to browse and go to Data64 installation folder and seed folder. There is a by default that you have two options, either 3D centimeter level or 3D millimeter level. For now, let's choose 3D centimeter. It says the resolution which will be used for the coordinates. For airborne data, it is okay to use centimeter level. For mobile, then you have better accuracy. It makes sense to use millimeter level. In case you're working with SpaceX, at the same folder you have also SpaceX files. In SpaceX, it's called template. So when you will get a message that you need to choose by which template you will create your new design file, then you need also to go to the same folder and to pick either centimeter or millimeter level. As I mentioned, I'm picking the centimeter, and I will save my new design file in DGN folder in Basic ALS. By saving, the design file will be opened. I already have my applications loaded into design file. In case you cannot see any data scan toolboxes or floating menus, then probably you need to go to utilities and MDL applications. Here search for the data scan as an available application and press load. By this step, the data scan application appear the same with other applications if you need data match, data photo, or some others. In SpaceX, you need to load IX apps, and you need to search those in Data64 installation folder and apps folder. So since we have the design file created, we can read the points and to investigate a bit what kind of data we have. Click search for the floating, the main one data scan menu, click on the file and read points. Go to Basic ALS folder, which was shared with you, and from LiDAR raw folder, pick the vascular dataset. While I'm opening this file, the software also gives me basic information about the file, how many points I have, also the format. I can pick the cloud type by loading this data set. As well, it gives me a quick display of the coordinates, so I could guess about the coordinate range. In case you're doing steps in SpaceX before loading everything, you need to remember the range, the round values, and then before loading in scan define coordinate setup, you need to put for the easting and northing the values from that display. In MicroStation, you don't need to do that. Usually it catches the values and it goes into the coordinate range. Sometimes when you are working with millimeter resolution, it gives like the smaller range. So in that case, it could be a good idea to check if you have the right one. But here I think we are good to read the points as it is. Then I will pick only every 10th point just to load everything and to have the extension of the coordinate of the data and to evaluate a bit. If you know that you have less powerful computer, you can also reduce the loaded point number by saying that you want to just load each 20th or something. It also gives you a display about available attributes for this file. I see that I have the color information. In this case, it was assigned just from the orthomosaic. And I will keep the line numbers from the file. So I just press OK. And the software reads the file. I see now the points in display. We can also check the different display modes. For example, at the moment, the points displayed by class, but it doesn't give much information because at the moment all points they are at the same class. I can change into color display, so I get the understanding that I will have some buildings in the project area, also a water body. There is also possibility to see by elevation, or for example by intensity, in case you don't have the color information. This display could give you understanding about the objects in the project. If I display by line, I can see that I have just everything assigned to the same line, so it's not specified. Then there is a setting for borders. As you can see now, I have a bit like higher objects a bit popping out from the display. In this display, if I would use 0, you can see that everything is more flat and it doesn't give you 3D objects understanding. This display mode also gives you ability to turn off the classes or change the variation of that. To get more information, like better understanding of the point cloud, we can also do a vertical section. So it can be done from the second button in the toolbox and pick the draw vertical section. By clicking in the view on which you want to display, you will get points there, or you can just set the view in which to have. So you can choose apply to second view, and immediately after you draw the section, it will be displayed in the desired view. The main data scan dialog, if I do the medium dialog, it gives me also some numbers. The dialog doesn't have any header information, so you can investigate what kind of data you have there in view fields, and then I can see like this one works as a header. That first column stands for the class, then I have easting, northing, elevation, and last as a distance. We investigated a bit into the data. We can move to the second step to draw the blocks, the boundaries of the blocks for the project. I will minimize the dialog again, and in the MicroStation on the Home tab, there is attribute section with the active level and active symbology. In the level manager, there is a possibility to edit those levels. So for example, I will prepare my levels. For example, the fifth I will call shapes for blocks. The sixth, for example, it can be reserved for created blocks that I will use in the project. Then the tool will create also labels, so I can place those there. I know that also I will need a layer for trajectories and GCPs. So now I created all those. I will change the active level for shapes for blocks. So for the designing blocks, we will use design block boundaries tool, and for that tool, you need to place some bounding shapes. They should be all on the same level, and as well it should be closed shapes, and like, or not closed, but they should cross each other, so tool could create later the closed blocks. For placing the block, the shape, I will use place shape. You can find that on placement section. And I will go just around the project area. It shouldn't be very accurate. It's more for the, and I will pick the close element to have shape completed. The next, let's place on the same level some lines. So lines should chop this shape into the smaller pieces. I will draw the line something like this, and in this direction for the software formulate 4 blocks. And since we prepared the required shapes, let's go to design block boundaries tool. It's under the first toolbox icon, and here we will pick to use bounding line work as we just draw, and as a line level, so it refers to those initial lines we placed, at least I placed, on level 5. Shape level refers to the level where this tool will design closed shapes, closed blocks, and those will be as a final ones for the project. Labels I will place on my 7 level, which I named by that. The software also calculates how many points will be in that block in case you have loaded points. You can design also the blocks without points, just then that calculation will be not done, but it is not vital to calculate how much points. In this situation, I know that I loaded each 10th point. I would say that as a minimum, I want to have at least 1 million point, and as a maximum, not more than 8 million points. I'm pressing OK, and I got my blocks. Now I will travel to default level to have not another than shapes for blocks level, so I will be able to turn off from my display. It can be done from this level display, and then you just make sure in which view you will be turning on and off. By clicking on the dialog, you will be able to get the right one. I have view 1, and I want to turn off the shapes for blocks, as well the labels. The only one which I keep is those formulated blocks, so I can see that they nicely done. And now these can be used in project creation. Before going to the project dialog, let's do one more preparation step. Load the trajectories, because that information we still didn't use. In TerraScan, there's a dedicated dialog for that, manage trajectories. It can be found also on the first icon in the toolbox, manage trajectories. And then in the file and set directory, you set the location where the files will be saved. The software recognizes, uses as a main format TRJ, and all files that you will import as a trajectory will be saved in that format in the set folder. So for that aim, let's set up the location. I will use again the same folder and just make a new one for the trajectories. The next step is to import the file, and because we will use just simple txt file, first let's create a trajectory format for that. It can be done in scan settings and look for file formats. This scan settings dialog has mainly, like for most of the tools, as a more deepened settings. In case you need to do a coordinate transformation, you go here and create your transformation. Also for some tools, you can change the levels or the display options. And now we will create user trajectory format. Click on that one and add. Now to see what kind of information we have inside the file and what fields, load the example, go to Basic ALS folder, and then trajectory raw. As I mentioned, it is just simple txt file. It has also header with explanation, and by this header I can set the names for columns. So as a first one, I have time, then northing, easting, elevation, roll, pitch, and heading. At the moment, I have also the header information. I want to have just purely numbers. So the first row can be removed by comment char, and here I put the first character. And by going to the format name, it is refreshed, and I see that the header now is removed. And give the format name. And you need to select this format after, then we will import the trajectory. Close the settings dialog, and settings will be saved by closing the dialog. So it's also the approval, that close button. Then let's come back again to the Manage Trajectories dialog, and here go to File and Import Files. Choose the same trajectory that was used as an example. For example, for me, I already got some format suggestions. I pick the one I just created. Do the same. The dialog gives ability to choose the system by which this information was collected. In our case, it's airborne system. In case you have mobile or something with lever arms, for example, then those values would be added by choosing the defined another one, but in this case, just simple airborne system. We don't do any transformation, so just none, but in case you need to change the coordinate system, you can define the transformation, and then just by loading, there is a possibility to reproject. It's user defined format for this trajectory, so we need to choose that we have degrees as input angles. For some coded in formats, as for example as beta, I think, it recognizes automatically the radians. And then we can thin a bit positions. Like the trajectory is not a line actually, it is just many points as a close by observations, and it's quite dense. So with this thinning positions, some intermediate points would be removed, but not too many. So like the line should stay in this given tolerance. After selecting the format and degrees, click OK. And the file should appear in this trajectory dialog. The same TRJ file was created also in our set folder. In my case, Basic ALS trajectory. If I click on the trajectory and show the location, it gives me a temporary display of the trajectory, so I can see where is the location and if it is a right location. So I see that everything is okay with that. Now what we need to do more, we need to split the trajectory, because at the moment we have just one trajectory as a one line. As a result, we would like to have separate lines, so we can see better from which line which point was collected. And if we will see that we have a lot of overlap, then these trajectories will help us to cut out some of the overlap. The software suggests some splitting possibilities. The split is just manual option. The automatic ones is cut turnarounds, but this one maybe is for mobile more suitable. We also have the polygon, so we can delete just by selecting that polygon and deleting outside, for example. Or while we have the point cloud loaded into the scan, these points can be used also for split at laser gaps. The tool searches for the gaps in the data. So for example, here's no data, the trajectory will be deleted as well because there is nothing. I will keep just the default for loaded points, all trajectories, 2 seconds gap. And now I see the short multiple trajectories. If we need to see those trajectories permanently, we can draw into the design file. I will choose for that a separate level, so I'm setting level 9 as an active one, and I can choose also a bit thicker line. In trajectory dialog and tools, there is ability to draw into design, and it gives the possibility to draw and as well to use different attributes. For now, let's draw just by line color, but in case you're interested at like where your line, your trajectory gets worse accuracy, or or something, then you can also draw by accuracy. It has also the thinning positions. This is just for drawing. It will not delete actual observations. So after selecting line color, click OK. And I can see my lines there. To check if everything is okay with the timestamps, we can just go to data scan, floating main dialog, and to line and deduce using time. At the moment I have display by line. I can see that it is everything in one, like it is assigned everything to one line. By clicking deduce using time, I can see that the points were assigned to different trajectories according from which flight line it was collected. So the timestamps, they are okay. Probably we will need to cut some overlap before starting with the classification. But now, after all preparation is done and we see that data is suitable for the next steps, let's close the loaded points. We don't need to save. And as a next step, we can create the project. Project dialog is under the first group of tools. Search for define project. At the moment is empty window because we don't have anything there. And as a first step, create a new project. Again, we need to select which cloud type we have. It is airborne lidar. Let's give also the description. Another thing is format, in which format the tiles for project will be stored. I would recommend to choose fast binary, as it is a bit faster comparing with other, and as well gives you ability to store all of the attributes that you can use in data scan. By clicking on the attributes button, you get another dialog, attributes to store, and here there is ability to choose which ones to store. I will add distance, normal vector, scanner and angle I will turn off as doesn't have valuable information for me, and I will store as well the color information and intensity. The software is able to work also with legal extra bytes, so if you have that information, you can import and store that. There is a choice where to store the tiles of the project, either together with a project file or separate. Usually I store together with the project file, so in case I copy somewhere, the software finds all blocks and load. In case you set something to load automatically, so if you travel between the projects, opening one after another one, then according to those selections, the trajectories and class information can be loaded together with the project, and you don't need to take care by checking if you have the right ones. Let's load the classes. You can find the classes file into Basic ALS and then DGN folder by name classes.ptc. So choose that one. And also check that trajectories would be loaded automatically as well. It should display you the link which you have at the moment in your Manage Trajectories dialog. The last part stands for the default block values. At the moment, we are not interested in those because we created our own shapes. But in case you don't add, like if you are not adding any blocks to the project and just importing the points, then the software automatically will create some grid which will tile your data. Press OK. The project is created. Now we need to save it. It doesn't save automatically. I will create a new folder for that, just LiDAR, and let's call the project. Since we have a definition, now we can add our blocks to the project and then import the points into those blocks. Let's select the blocks. So I just choosing the element selection from the home tab in MicroStation ribbon. And I know that I have everything on level 6, so I just click on level 6 and my blocks they are selected. After that, let's go back to project dialog and click on add by boundaries. In case, like now we just created manually those blocks. In case you have some grid or the buffer zones, you can also add as a shapefile and then just also select, and you can add as a boundaries those to the project. If you're working, for example, with power lines, you can use create along tower string, and then the software automatically creates the corridor along the power line. This time we're using simple shapes, just add by boundaries. We don't have any text inside. The software asks us how I want to name it. And I will pick just selection order. In case you have the text element inside, you can choose selected strings, and then the blocks will get name according to that text inside the block. I see that at the moment I don't have any information inside my blocks. It says no file. So we need to import the points into the project. It can be done from the project dialog, the same one where we do everything related with the project. You just click on the file and import points into the project. Choose the same and the only file for that folder, from that folder. It gives us again the same information. So I don't want to apply anything, load everything. In case you have, I don't know, the grid created, and you know that maybe not all blocks will be filled up with the data, you can click delete empty blocks and the software will automatically get rid of the empty ones. Merge small blocks can be used, and some blocks you will get just, I don't know, 1000 points and it's too small to work with that. You can also merge into the neighbor one. The line numbers can be deduced either by loading points, or later we can add the step as a macro step. I will load just as it is. And also by loading those files, I can see that the FBI files were created in my LiDAR folder together with PRJ file. I got the report, how many points was imported, and I see that the blocks, they are not empty anymore. Before we used just simple read points. Now then there's a project definition. You can use also another option, open block. So in data scan floating dialog, open block, and then click inside the block. By this, just one block is opened. And also save the project again, so any changes for the project would be saved. When you're running the macros or classification, you just run the step and the blocks will be changed and saved automatically. That saving is more about project definition if you're changing something. The idea of this project is to chop the data into the smaller tiles, so you can load, like before we just loaded each something point. Now I can have the full density. In case you are working with big amount of data, then of course the splitting into the smaller pieces gives the ability to process the big areas, to run automatic classification steps, and so on. And while we have the project created, now we will have ability to apply the steps on the project. And it will be our second part of the training with the classification steps creation.